What's going on, you guys? Welcome back to the channel. And today's video is going to be a project showcase of Jetpack Joyride, as well as a quick code showcase. It's going to be a little different than our long form code tutorials because I'm not going to go line by line through the code. I'm more going to explain that if you're the type who grabs the GitHub link and wants to sort of know what's going on with the code, I'll explain my thought process behind how this was made, and you don't have to watch a multi-hour code long if you don't want to. So I have wanted to make Jetpack Joyride for a little while. It was essentially the runner-up project for our 5,000 sub special. I did a poll on the channel and Donkey Kong won, and in hindsight, like I'm pretty excited that we got to build out Donkey Kong. That was an insane amount of work, but it came out really, really cool. But Jetpack Joyride had a lot of votes as well, and I finally got around to making it. And something that actually the subreddit our pygame has said a few times when I've shared some of the bigger projects is that, you know, they think the projects are really cool, which I appreciate, but that sometimes like they don't feel like they need a 4.5, 5 hour video or even a 2 hour video to know what's going on, because most of them want to grab the code from the GitHub, dig into it themselves, play the game a little bit, and then sort of enhance it from there. And so what I thought would be a good idea is to sort of, when I do the long form code tutorials, which we rolled out earlier in the week, is to also include a video where we just sort of play it, talk about the functionality of it, and then hopefully there's a somewhat lower like barrier to entry for people to find the content and find the channel. Because ultimately the goal of my channel is to get people excited about STEM concepts and engineering and to feel confident programming and building cool stuff. So if rolling out a 2 hour video gets all the people who are really gung-ho about like programming line by line and getting it, then maybe rolling out a 10 or 15-minute video where we showcase it could get a different group of people in the door. So without any further ado, I guess let's talk about the code. And I'll just say, if this is your first time on the channel, maybe consider subscribing to the channel. We do a ton of cool Python projects as well as Arduino and other stuff. So just be sure to stay subscribed for all the new content. And to talk about the code really quickly, this whole project only ended up being around 270 lines of code. And I say only despite the fact that that's quite a bit of work. I say only because some of our bigger projects like Pac-Man, I believe, was over 1,000 lines of code, and I think Donkey Kong was close to 1,000 lines of code. And so for a full game that has a lot of functionality in it, I was actually kind of impressed that it stayed down to 270 lines of code. But so basically, I'm not going to dive too much into the specifics of like setting up our pygame game. A lot of this is boilerplate. And if you grab the GitHub link in the comments below, you don't really need to know what every single thing in here is doing. If you're an absolute beginner to pygame, I suggest you check out the like intro to pygame playlist on my channel. I'll probably leave a link to it somewhere above. But that I cover the basics of setting up a pygame window and all of these things. Mostly the first 50 lines, 40 lines of this code are initializing variables that we need later on when we build it. And then this little block of 5 here in the beginning is interesting and worth talking about. This is actually everything you need for when you boot this game up in the very beginning to read the high score and the lifetime distance run that you've played. So this, for this, I drop a text file called player_info.txt into the same folder as my main.py file. And the only thing I put on there is 2 lines of numbers. So the top one is your individual run high score, and then the bottom one is the lifetime distance that you've run while you play Jetpack Joyride. So that's a really kind of cool thing to keep track of, and this functionality just extended out would be how you add progressively more essentially player history and player tracking to your programs. So that's just a cool little bit of code. It's really as simple as read the lines from this text file, and then assuming you know what order they come in, then you can just store them in the variables. And since we later later in this same project, we define what gets stored in that text file, we can be pretty confident that we know what we're reading out of it. There are ways that you could add error handling and make this a little more robust, but we write into that file later on 2 rows of integers with the high score and the lifetime distance ran, so we can be pretty confident about the content of it. And then just make sure you close it out to essentially release the file. And then after that, we set up the main game loop, which is just basically saying run equals true, while run, I want to timer.tick, which controls the speed of the game. And then you start drawing it, you start defining the different like functionality that needs to happen. And you can do this in sort of an abstract way and say like, okay, if I need a new laser obstacle, generate the laser. Every iteration of the loop, I need to draw the screen onto the screen. If the pause functionality has been selected, I need to draw pause onto the screen. If there's no rocket active and it's not actively paused, then I need to start counting towards triggering a new rocket. So a lot of this just sort of, you code it because if you're saying it out loud, that's the next thing you have to do. So if you watch the full code along, you'll see I'm basically like, I think the next thing we need to do is draw something on the screen. And then we make the draw screen functionality. And I'll be like, okay, it's time to draw the player. And we'll draw the player on the screen. And I'll say, okay, we need to check if the player is colliding with the lasers, the rockets, or the top and the bottom. So we make a check colliding function. And so that's the beauty of object-oriented programming, is you can essentially say, I need to do X, and then you make a function to do X, and then your code that does that function is in there. And it's a very logical way of making a program. I'm not perfect at it. I'm self-taught, and a lot of the time some of my viewers will throw in, hey, this would be more Pythonic, or this would be a little more object-oriented. And you know, the beauty of Python is that for beginners, once you get your code working, that's kind of the goal, right? And then once you're sort of in that intermediate range, it becomes a lot of clean up, enhance, and make better. But anyways, that's a little bit of a tangent. I want to talk about the game handling, because in pygame, you set up this for event in pygame.event.get, essentially this nested series of for loops with if, else, if. But basically, the first one you always need to set up is if the event.type is pygame.quit, set run equal to false. Even if you don't do it exactly this way, you need to have an event from the first time you boot this function up that will set run equal to false, because otherwise you will have an infinite while loop. This while run, you have to have a way of exiting that while loop. So that is why this is the first thing that we always do. And you can actually see the modified player info is when we save information right before quitting out of the function. So that's how we capture, like, if you quit, if you press the X button, but you've run 10,000 meters, we still want to count that towards your lifetime running. So that's something that we do in the modified player info function. We'll talk about in a little bit later. But then the actual game mechanics of event handling for Jetpack Joyride are very simple. It's basically the space button being pressed down makes me fly up, makes me activate that booster, and then when I release the space button, it sets booster equal to false. And then beyond that, everything else here has to do with the pause button. So like pressing the escape key is what I picked to bring up the pause menu and release the pause menu. And then when I'm on the pause menu, there's a button on there that lets me restart my game and quit my game. And that is it for event handling. Basically, the buttons on the pause menu, triggering the pause menu, and then the space bar to be able to fly up and down. A lot of the times, these famous iOS apps had a very basic game mechanic. And so there's nothing particularly complicated going on in Jetpack Joyride. And then down below, this is where I will admit my code maybe looks a little bit like spaghetti code, because a lot of this could have probably been extrapolated, abstracted into a function. But I felt like it was pretty straightforward and it had to get called every function, and it's pretty easy to read. But basically, if we're not paused, we want to add the game speed, which gets progressively harder the longer we play, to our total distance. And if we're using the booster, we want to move upwards, change our Y velocity towards the top of the screen, which actually is somewhat counterintuitive. It's subtracting gravity out. But otherwise, we want to fall, which is adding gravity, because the higher numbers in pygame are actually the bottom of the screen and 0 is the top of the screen. we want to fall. And then if we're colliding with the floor or the ceiling, and we're supposedly falling or boosting, then we need to set y velocity equal to 0 and not let the player change anymore. And then just modify the player's y coordinate by that velocity parameter. So that happens as long as it's not paused. And then down here, this was a little bit of like guess and check what max speed feels good. How often do I want to spawn a laser? How often do I want to change the background? So really these things, if you were looking for an opportunity to sort of tweak the game, tweak the parameters of the game and see how that changes things, you could spawn lasers less frequently. I essentially spawn a new laser as soon as the previous one clears, which I thought was actually pretty good. And then I let the game speed get to a max of 11. You were pretty much flying at 11. So I felt like that was pretty good. And if you manage to get to 50,000 on this game that I built, like you're pretty good. And then every 500 pixels, I just randomly generate a new background. So, or 500 meters run, I generate a new background. So that's just a fun little game mechanic. And then I put the various times that we could restart. So we want to restart if you hit an obstacle. We want to restart if you click the restart button from pause. And then we want to restart when the game boots up. So I put all of that just into a spot that says, if restart command, do this series of things. And then the last thing I just do is I check if the current distance is greater than the previously stored high score, and I overwrite the high score at the distance. So this is while you're actively running. If you are beating your previous high score, it'll immediately show on the screen that you have the high score. And then this pygame.display.flip just goes on the bottom of your loop, but still inside the while run. And then outside of the while run, you do this pygame.quit so that when you press the X button, the game is over. It's pretty simple. There's not a lot of crazy stuff in here. I think maybe let's dive into the sub functions very quickly. The first one that I set up was draw screen, and this really, it looks like there's a bunch of things going on, but they're all simple. So we're filling this overall screen with black. Then I draw a semi-transparent. That's why I draw it onto the surface, because surfaces accept an alpha parameter. I've talked about that in the previous 2 videos on the channel, pause menu and how to draw transparent images. But we use that background color with the transparency setting, and then blit that onto the screen. We define the top and bottom rectangles that we check for collision with the player to see if we're able to keep flying up or keep falling. And then these, for eye and range line list, all of this code is just drawing those vertical lines essentially every quarter of the window to give the illusion of the overall board moving to the left. So basically, they will speed up with game speed, and all they're really doing is sliding to the left so that we feel, even though our player's X coordinate is not changing, we feel like we're continuously moving forward. So that's what we're doing at the line list. And then we're checking if they go off screen, just reset them over to the right. We draw the laser in this function. So essentially this is the main line of the laser. And then these are just those end caps, those circles on either side of it. And then we display the distance and the high score. That's all that's going on in this draw screen function. So even though it's 20 lines of code, it's pretty basic functionality. Draw player is actually 30 lines of code. It's even simpler. It is defining a rectangle for the player's hitbox, and then there's some checking to do what we should do because we animate it with pygame rather than animating it with different images that we just blit onto the screen. So that's why it looks like there's a ton going on here. But to break it down really simply, regardless of what state the game is in, we draw the white rectangular jetpack, the orange body, the orange head, and the black eye every time. We always pass the player's hitbox back, and then the only things we're checking for in here are if the player is not on the ground and the game is not paused, then or the game is paused, then we just draw the feet vertically. And then if we're actively boosting using the spacebar, we draw a flame, which is red, orange, and yellow. And so if I can just show that really quickly, when we're in the air, we just draw these 2 orange and yellow stumps for legs straight up and down. And then when we're actively flying, we draw these 3 colored ellipses on the background for a flame effect. And then the rest of the code is just checking to see if we're on the ground. And then actually it's like more than once per second because I used a counter variable of 40. But so basically every 1/6 of a second, we change frames, and all that's doing, this is saying we have a yellow leg and an orange leg, and it's just changing their legs in their 4 positions. So the draw player function looks like it's 30 lines of code, and you could boot it up and be like, oh my gosh, what is going on here? It's really pretty simple when you break it down. Check colliding is actually the simplest. So we have a collision list just with 2 parameters in it to check if we're colliding with the top and colliding with the bottom. And then to check if we're colliding with a laser or a rocket, we just set restart to true. We don't have to do anything complicated. Like, we need to know continuously if we're colliding with the top and the bottom, because that's how you know whether you're able to keep flying or keep falling. But if you hit a laser or you hit a rocket, just reboot the game. So the check colliding function is very simple. Generate laser, I'm kind of proud of this. Basically, we randomly decide if the next laser is going to be horizontal or vertical. And then we also put a little element of randomness to see how far off the screen to the right we should draw it. So it's anywhere from just barely off screen to the right to quite a bit off screen to the right. And then I did put a little match case in here just to show you can do this instead of an if-else if by saying I want to match on the value of laser type. If it was a 0, that means draw a horizontal. If it was a 1, draw a vertical. And then we define a new laser just by saying its X position and its Y position. And that's all that we're doing. And then we return the new laser function, and that's it for generate laser. We then draw that on the draw screen function we already talked about. Draw rocket is a little bit more complicated because the rocket has 2 modes. The rocket has before it has spawned, and then it has while it's actually on the screen. And so I'm kind of proud of this as well. We keep track of the mode inside the main game loop. We basically say when it's time to spawn the rocket, give about a second or 2 of warning with this dark red rectangle with an exclamation mark. And so to boot it up and refresh everyone's memory, the rocket in mode 0 is when we get this little red rectangle with the exclamation mark, and then it's sort of able to move and do a certain level of tracking the player's Y coordinate. And that's what we do with these 4 lines. We're just saying if my Y coordinate is above or below the player essentially that I'm targeting, then I'm going to move up or down. But then once it's time for the rocket to launch, we don't change its Y coordinate anymore. We change its X coordinate, and we move it by a speed of 10. And actually, I'm looking at this now. If you've downloaded the GitHub, yeah, 10 plus the game speed. So it flies to the left across the screen pretty aggressively. And basically, we draw it in 2 different ways, too, based on the mode. So this is the warning, the dark red with an exclamation mark on it. And then this is the rocket. It's actually the red rectangle with an orange flame behind it. And we do all of that inside the draw rocket function. Draw pause is not particularly difficult once you understand kind of the drawing semi-transparent. So the first thing we do is we draw that dark gray rectangle with transparency on over top of the entire screen. And then we just put some text and some rectangle on there that says, hey, you paused the game, but you can resume with the escape button. Then I draw a restart button and a quit button onto the screen, as well as the lifetime distance that you've run, just because it makes a little more sense in my mind to show that on the menu than to show it constantly on the screen. But reasonable people could disagree there. And then I return the restart button and the quit button because we need to do that in our event handling. So that's kind of all that's going on in draw pause. And just to remind you guys what the pause menu looks like, you're in the air, it's paused. You have this semi-transparent gray mask over the whole screen. It tells you that you can resume with escape, or you can click restart or quit, and it shows you your lifetime distance. And then the last sub-function in this whole thing is modify player info, which is where we check if we have a new high score, and we add our lifetime distance, we add the last run to it, and then we save it using write. So file equals open playerinfo.text write, which is the opposite of read that we did to pull that information in. And then we write the new high score to the function with a new line character, and then we write the lifetime distance run, and we close the file. And we call modify player info every time we restart, so that when it's a new run, we go ahead and add the previous run's distance to the player.info. And then we also do it when you quit. So if you press the quit button, or if you press the red X, we call modify player info first. So that is all that is going on inside of this code. I think it was a ton of fun to build, and I'm really thankful so many people vote on and give their thoughts on kind of the direction of the channel and what we should do next. And I really appreciate everybody watching this. I hope if you guys are interested enough that you'll follow along with the code along tutorial and kind of understand how the overall project goes. But be sure to let me know in the comments below how I could have made this better, what you'd like to see next on the channel. If you'd like me to do more of these kind of walkthrough code alongs in addition to the long forms, let me know that as well, because I may circle back and do one of these types of things for like Pac-Man and Donkey Kong to potentially make a shorter form video to expose a wider audience to that content. So again, thank you everyone for watching. A massive thank you to my Patreon supporters. And as always, good luck with your code. Thanks for watching. See you next time. Bye.